The hottest new programming language is English. Andrej Karpathy, co-founder of OpenAI and former artificial intelligence lead at Tesla, said that in 2023. 2 years later, it was not a metaphor. It was a job description. In 2026, 92% of American developers used AI coding tools daily. 60% of all new code written globally was generated by AI. Developers no longer wrote software line by line. They described what they wanted, and a machine wrote the implementation. The term for it was vibe coding. Collins Dictionary named it Word of the Year for 2025. Linus Torvalds used it to build a component of a Linux project and documented it in the README. This was not a productivity story. This was a structural shift in how technical work gets done, and it was happening everywhere at once. The interface for everything technical was converging on a single input method. Describe what you want. The machine executes. The syntax, the query languages, and the configuration commands that used to define entire careers were being absorbed into a layer of AI that translated plain English into machine executable instructions. The toll booth between intent and execution was closing. And the question that emerged was simple. If the syntax no longer matters, does the understanding underneath it still matter? The answer arrived through 3 fields: coding first, then cybersecurity, then data analysis. Each one followed the same pattern, the same shift, the same silence where the safeguards should have been. Platforms like Cursor let a developer describe a feature in plain English, and the AI generated multi-file changes across an entire project. Lovable and Bolt.new went further. A single sentence could produce a working full-stack application in under an hour. Lovable hit $300 million in annualized revenue by January 2026, less than a year after launch. A warehouse owner in West Virginia used AI to build custom shipping software in a day. A designer in Oakland with no technical background shipped a complete application on her own. In April 2026, the Association for Computing Machinery published a formal tech brief warning that vibe coding often skipped core engineering practices, the ones that ensure systems are secure, reliable, and maintainable. But the barrier between idea and working software had compressed from months to hours, and there was no reversing it. Then came cybersecurity, and here the stakes changed, because this was not building a web app. This was defending networks, infrastructure, and data. For most of the history of security operations, hunting for threats meant writing queries by hand, using systems like Splunk's search processing language or Microsoft's Custo query language, known as KQL. A threat hunter needed to know the schema of their log data, meaning which tables held which events and which fields contained IP addresses versus host names. That skill took years to develop. Microsoft built a system called NLL2KQL and embedded it in Security Copilot. A Security Operations Center analyst types a question in English, such as the question, "Show me all failed login attempts from external IPS in the last 48 hours," and the system translates it into a working KQL query, runs it, and returns results. Microsoft's explicit pitch was that this allows junior and first-tier analysts who aren't familiar with KQL to easily hunt for threats. The pattern extended beyond threat hunting. Large language models were mapping common vulnerabilities and exposures records to MITRE ATT and CK techniques, drafting detection rules, and extracting indicators of compromise from unstructured reports. Data analysis followed the same path, questions that once required fluency in structured query language, known as SQL, could be typed verbatim into tools like Julius AI or ThoughtSpot. Natural language to SQL accuracy now hit 86 to 95%. Across every domain, the same transformation was underway. The syntax that used to be the gatekeeper was being replaced by natural language. If this was where the story ended, it would be straightforward: progress, democratization, barriers falling. It was not where the story ended. In October 2025, Amazon laid off 30,000 engineers and mandated 80% AI tool usage across its development teams. 3 weeks later, a 6-hour shopping outage traced back to AI-generated code that passed automated review, but contained a logic flaw no human engineer had checked. The incident was not caused by a sophisticated attack. It was caused by code that no one had read. This was not a bug. This was the system working as designed, a system where the human review step had been removed, and nothing had replaced it. And the same failure was already embedded inside security operations centers around the world. The AI hallucinated, not occasionally, but regularly and confidently, in ways that looked correct to someone who did not know better. One user on the Azure Sentinel subreddit described their experience with Security Copilot, saying, "I find this prompting very annoying. The Copilot produced plausible-sounding queries that returned wrong results. It missed context that an experienced analyst would have caught immediately. The syntax was valid. The logic was flawed. And without knowledge of KQL, the difference was invisible. This was not a bug that would be fixed in the next release. It was a structural feature of how large language models worked. They generated the most probable next token. They did not verify their output against ground truth. When an environment did not match their training data, which was always because every network was unique, the output degraded in ways that were invisible to someone without domain knowledge. Gartner found that while 70% of large security operations centers would pilot AI agents by 2028, only 15% would achieve measurable improvements without structured evaluation. It was not because the technology did not work. It was because they did not have the human capability to make it work. Beneath that was a deeper problem. If the AI handled all the investigative legwork, would junior analysts ever develop the skills to become senior analysts? The traditional Security Operations Center career path was built on manual work, triaging alerts, writing queries, investigating false positives, and developing intuition for what looked normal and what did not. That repetitive, often boring work was where expertise came from. Automate that entire training ground, replacing the instruction to investigate it yourself with an instruction to review what the AI decided, and a generation of practitioners emerged who could evaluate AI output but had never developed the independent judgment that evaluation required. The cybersecurity workforce gap stood at 4.8 million unfilled roles globally, but the 2026 SANS GIAC Workforce Research Report, unveiled at RSAC 2026, reframed the problem. The issue was no longer headcount, it was skills. When organizations were asked to choose between not having the right staff and not enough staff, 60% identified skills gaps as the greater problem, a 20-point jump from just 4 points the year before. San El Chao. Chief AI Officer Rob T. Lee said it directly. This is no longer a story about filling seats. Organizations have people. The people they had did not know the right things. 59% of hiring managers admitted they did not yet understand generative AI well enough to determine which skills their teams would need. Into that vacuum stepped a seductive idea: just learn to prompt. Why spend months learning KQL when English produced a query? Why study SQL when tools generated it? The logic was internally consistent. If the machine handled the translation, only the intent mattered. But the logic depended on an assumption the data did not support, that the person writing the prompt could recognize a wrong answer. The warehouse owner shipped software in a day. The question no one asked was whether he could debug it at 2 in the morning when it broke. The junior analyst generated queries in seconds. The question no one asked was whether she could tell when the results were lying. These were not hypothetical concerns. They were the same pattern, repeating across every field where syntax had been replaced by suggestion. The barrier to entry fell. The barrier to expertise fell with it. And no one noticed, because the tools made everyone feel like an expert, including the people who were not. In cybersecurity, the greatest vulnerability was never the code. It was the assumption that a tool could substitute for the years of failure, repetition, and pattern recognition that produced a mind capable of knowing when the tool was wrong. The toll booth between intent and execution closed. What opened in its place was a gap between the people who could ask and the people who could verify. That gap is widening, and the data on the other side of it is being read by fewer and fewer people who understand what they are looking at. The investigation is not complete. It is ongoing, and the evidence is being generated faster than anyone can examine it.